So today we're going to distinguish between a simple random sample and a stratified random sample, or a cluster sample. There are two different types there. Stratified and cluster, they're two different things. And maybe talk about some advantages and disadvantages of the sampling method. Now, a simple random sample, we just take the entire population and we select a bunch of people from, or individuals, they don't have to be people, from the population without regards for any differences that there might be within some subgroups within the population. Now let's think about if we were selecting books for some reason. Now, not all books are created equal. There are fiction books and non-fiction books. And even within fiction books, there's romance novels, there's thrillers, there's horror novels, there's historical fiction, science fiction. Lots of different categories of books, and all of them have different characteristics that might make them unique and different from the rest of the population. So if we really wanted to find out some information about books, we might have to look at the various different types of books in order to do that. And that's where a stratified random sample comes in. Okay, is when we have a situation like that one. So a stratified random sample, we classify the population, okay, into groups of similar individuals, okay, called strata. Now, I always tell people, it's essentially what you're talking about is with, if you're using people, you might classify people by race. You might want to find out something in different attitudes that different races might have about a particular topic. You might want to group people by race and then start sampling within the various races. You almost would do gender as well. Okay? You might classify male and female and start asking questions that way. Okay? Once you've classified the people, you then okay, choose separate simple random samples from each strata. Okay. Now, a cluster sample, we also classify the population into groups. However, when we're classifying with a cluster, it's not about what the individuals might have in common with each other than they just happen to be in the same place. Okay, so in a cluster sample, we classify the population, okay, into groups of individuals located near each other. Okay? So I always say, it's like in a stadium. You might choose a section. Like section 241 in the stadium. You might choose section 241. And then all the people in section 241 would be your sample. Okay? You choose a simple random sample of clusters. All the individuals in a chosen cluster become part of the sample. Okay? All the individuals. And there's a little mistake here, I better fix that. Spell that correctly, be helpful. All the individuals. Okay, so that's a cluster sample, and you can see how when we talked here about strata, they have significant similarities between individuals. When you're talking about race, when you're talking about gender, there are significant things that are similar about the individuals within the strata. But in a cluster, it's kind of arbitrary that it's section 241, or you might choose, if you're talking about school, you might choose first hour and where a person is first hour, and it's all random. And within a cluster, you're likely to have a lot more variety than you would within a strata. Okay. All right, let's look at an example here. A school librarian wants to know the average number of pages in all books in the library. Okay. The library has 20,000 books arranged by type, fiction, biography, history, and so on, and shelves that hold about 50 books each. You want to select a simple random sample of 500 books. Okay, so let's look at A. How would we do that? A simple random sample. Well, we would simply number the books 1 to 20,000. Okay. Use randint or some other technology, 1, 20,000, right, to get 500 unique numbers in this range. Make sure you say unique. Which means it's likely that we would have to have more than 500 numbers, because when we use randint, we're likely to get the same number twice, and we can't have the same number twice. They have to be unique numbers so that we're actually getting 500 books. And then we would use the books that correspond to the chosen numbers. Now, could you put all 20,000 names in a hat in a book and then draw equal sized pieces of paper, mix well, and draw 500? Absolutely. Absolutely you could. Now, not very realistic, but on the AP test they wouldn't care. Okay, a stratified random sample. Okay, we'd first classify books into categories such as fiction, history, etc. Okay. Determine how many books fall into each category if 2% of the books are science fiction, then 2% of our sample should be science fiction, etc. Okay, we want to make sure that we're doing it in a way that's representative of the population. Now, so number the books within each strata and use a simple random sample as described in Part A for each strata. Okay. Now, so let's look at C. Explain how to select a cluster sample of 500 books. Justify your choice of clusters. Well, our clusters are, it says that they're on shelves that hold about 50 books each. Okay? Shelves that hold about 50 books each. So we're going to want to select, we want random sample, okay, a cluster sample. Those are, our clusters are going to be the shelves. So let's go ahead and do that. Let's see. The shelves are our clusters. Okay. Number of the shelves from 1 to 50. I put the numbers on equal sized pieces of paper. In a hat. Mix well. And draw 10. Use the books, the 50 books, on each shelf, each of these shelves, to make up our sample. Okay. Now, of course, when we do that, they're on the shelves, we may get a bunch of history, we may get fiction, we may get science fiction, we may get historical fiction. We can get a lot of mixes in there that will make it a little bit different.